So I would like to start by thanking the Secretary for those truly inspirational words. I can put my hand on my heart and actually say they are the most inspired words I've heard from a Secretary or from the department. And looking around the room at the faces of my science community, I know that they shared that perspective with me. So thank you very much for your introductory remarks. We wish the Minister a quick recovery. For those of you who I've not yet had the opportunity to meet, I'm Nicole Webster, the Chief Scientist of the Australian Antarctic Division, and it's my job today to introduce our program to you and to also help navigate you through the agenda that's today's Science Symposium. Okay, so as we've heard, science is the way we understand the natural world. It's the very foundation of our decision making. So making science accessible and relevant to the needs of decision makers is therefore critical to ensuring that the best policy options get identified and pursued. Today we've come together to share the importance of Antarctic science and really step up our collective efforts to design together a program of research that meets our national needs. Recently, the Australian Antarctic Division formally asserted that science is at the heart of our program and that our organisational decisions and resources would really reflect this, science as a core value. The timing of this commitment is absolutely critical. We are now in a world where we must look towards science and technology to find answers that will help us secure a sustainable future. As the banner from the recent Antarctic Treaty Consultative meeting in Berlin so eloquently stated, from science through policy to protection. So today is a celebration and sharing of Antarctic science. Science underpins the very origins of Australia's relationship with Antarctica. The first Australian to winter over on the Antarctic continent was a young Tasmanian physicist, Louis Benacchi, who travelled on the 1898 Southern Cross Antarctic expedition. From this visit, he concluded that while Antarctica held poor prospects for commercial advantage, Antarctic exploration was of capital importance to science. Benacchi's observations at that time were absolutely visionary. The future of the polar regions is intrinsically linked to the future of the entire planet and our own destiny, because Antarctica and the surrounding Southern Ocean are the key drivers and modulators of Earth's oceanic and atmospheric systems. There is, of course, still much to learn, but there is no doubt that understanding changes in Antarctica and the Southern Ocean will be key to preparing Australia for different climate futures. Take, for instance, research that assesses the vulnerability of Antarctic ice sheets. Sea level projections for the year 2100 currently range from a few tens of centimetres to over a metre. The greatest uncertainty is the contribution of Antarctica. In the context of urban planning here in Australia then, the impacts of this projected sea level rise for our exposed infrastructure and for our coastal management are huge. In the context of our water security, recent analyses of 2,000-year-old Antarctic ice cores have shown that drought risk in East Australia is actually much greater than previously thought. Globally ambitious science is therefore needed to elevate protection of Antarctica and Australia. To understand Antarctica and all of its interconnections, we really need to be studying it as an integrated system. Indeed, most of the critical scientific uncertainties that we have actually occur at the boundaries of the cryosphere, between the ice and the atmosphere and between the ice and the ocean. But science itself will still not be enough. We also need to be documenting and communicating our science knowledge to the public and to our decision makers to best support Australia's climate policy our risk and mitigation planning, and our policies for disaster management. We have a really clear vision for the Australian Antarctic program, a science program that is innovative, integrated, and collaborative, where we are purposefully positioned to not only deliver science for immediate management and policy needs, but where we are also answering the challenging big picture questions. Questions like, how fast is Antarctica responding to climate change? What are the irreversible tipping points? What do changes in Antarctica and the Southern Ocean mean for us here in Australia? And how can we manage or mitigate those changes? Answers to these globally important issues needs really audacious science. Science that can only be delivered by working collaboratively, respecting, valuing, and using each other's insights and knowledge. So to achieve this, Australia is in the process of developing a decadal plan to establish an integrated, co-designed Australian Antarctic science program for the future. The plan will be informed by our national and international policy needs, and it will identify the highest priority science required to address those needs. The decadal plan will also identify the key capabilities, including the skills, the technology, the data, and the infrastructure that's all going to be required to support that highest priority science. Importantly, it will also explore the alignment of Australia's science priorities with those of other national Antarctic programs, and we will be looking for opportunities to collaborate in areas of mutual interest. And we are really well positioned to dream big. We've just taken ownership of our new icebreaker, RSV Noina. Noina is packed with innovative capabilities and technology that will extend our science reach into new frontiers like never before. Echo sounders on movable keels to map the ocean floor. A moon pool window directly into the Southern Ocean, enabling us to make our observations no matter the weather or the sea ice cover. A wet well that allows us to sample delicate marine life directly from the Southern Ocean without damaging it. And a trawl deck that can deploy anything from deep sea corers right through to autonomous underwater vehicles. And we've also just recently revamped our overland traverse capability, enabling us to undertake deep field science into areas of East Antarctica which have previously been completely inaccessible to science. All of this provides us with unprecedented science opportunities and ensures that we will be an international leader and collaborator of choice for Antarctic and Southern Ocean science. Now, for decades, Australia has been monitoring marine and terrestrial wildlife, oceanographic processes, atmospheric processes, ice sheet dynamics, and sea ice. But as we move forward, the Australian Antarctic Division plans to integrate and expand upon that work by establishing an East Antarctic monitoring program. This program would commit to sustained observations of our essential biodiversity, climate, and ocean variables. And all of this would be underpinned by a strategically prioritised monitoring plan. Such an integrated and sustained observing system will enable us to detect change at a range of spatial and temporal scales. And equipped with that information, we will be much better placed to reliably forecast and manage the Antarctic environment. The timing for this is perfect. The East Antarctic Monitoring Program could also take advantage of recent technological developments in data science, in remote and automated sensors, in spaceborne instruments, and in autonomous vehicles like long-range drones. So this convergence of the technological advance and that scientific imperative is also compelling us to establish a more ambitious program of big data-driven science. So we've just commenced scoping of a new integrated digital East Antarctica program. Improved and expanded acquisition, integration and analysis of East Antarctic data will really underpin the cutting-edge simulation and modelling science that's really required to answer those big picture questions that I discussed. And it will provide decision makers the tools that they will actually need for evidence-based policy making. That is absolutely critical. The Secretary touched on it. We need to be able to provide our decision makers with the tools that they need for evidence-based decision making. Our marine program into the plankton, the krill, the fish, the seabirds and the whales will also expand under our Southern Ocean Ecosystems program to ensure that we continue to have well-managed and sustainable Southern Ocean fisheries and that we are adequately protecting Antarctic wildlife. Not only does this provide the best evidence-based scientific advice to our Australian government, it will also enhance Australia's leadership and influence in CCAMLR, the Convention for the Conservation of Antarctic Marine Living Resources, in the IWC, the International Whaling Commission, and in ACAP, the Agreement on the Conservation of Albatross and Petrels. Excitingly, and I hope that Phil is going to touch on this later today, we are also in the process of constructing a new environmentally controlled krill aquarium in Hobart. This will enable us to reliably simulate Southern Ocean conditions and greatly expand our experimental work to new Southern Ocean species, and also to determine how krill, which are the very basis of the Southern Ocean ecosystem, and Rob will touch on this in his presentation, how all of the different life stages of the krill are actually going to be responding to a warming and acidifying Southern Ocean. Our environmental stewardship program, which Andy will talk to, will really strengthen Australia's efforts to meet our legislative and treaty obligations by implementing a range of environmental management and remediation projects. And this includes the Cleaner Antarctica program, which involves systematic evaluation of all of the environmental risks associated with Australia's legacy waste in Antarctica. And it will develop a multi-year actionable clean-up strategy for those legacy waste sites. Our environmental stewardship program is also in the process of developing an environmental impact minimisation strategy for the entire Australian Antarctic program, addressing important issues such as biosecurity, waste management, and very critically, emissions reductions. And our climate program that Tas van Ommen will talk to will really be accelerating Australia's efforts to quantify change in both sea ice and the East Antarctic ice sheet. Improved representations of sea ice processes in our numerical models are really critical to ensuring that we have the best weather forecasting, that we have the right climate projections, and that we have policies for conserving and managing the Southern Ocean ecosystem, including our important commercially valuable fisheries. And we will also be amplifying research to quantify the vulnerability of key regions of the East Antarctic ice sheet. This science is urgently needed to better constrain projections of sea level rise. East Antarctica is Australia's backyard, and we are uniquely positioned to drive this research to complement the substantial international effort that's currently focused on the West Antarctic ice sheet. Our observations and monitoring of the high latitude atmospheric processes will also continue, and that will be used to validate and improve climate models and provide climate relevant policy advice, including for our Montreal Protocol obligations to protect the Earth's ozone layer. And our ice core team will be using past climate records extracted from ice cores to understand present and future change, with our ambitious goal of extracting a 1,000,000-year-old ice core from Little Dome Sea, which is 1,200 kilometres inland from Casey Station, actually commencing this season. This will address a really long-standing mystery in Antarctic science. Around 1,000,000 years ago, something caused a shift in the regular cycle of ice ages, from one ice age every 40,000 years to one every 100,000 years. This change, which was known as the mid-Pleistocene transition, also coincided with a shift from a warmer climate state with smaller ice sheets to a colder climate state with larger ice sheets. An ice core that extends 1 million years into the past will really answer this fundamental question of what actually drove the change in the cycle of ice ages. Now, science is never easy, especially in remote and extreme Antarctica. But Antarctica is where we need to be. Achieving the scientific ambition that I've set out today is actually quite daunting. Our science challenge will be to reach for solutions in a series of measured steps, integrating learnings from physics, chemistry, and biology, making enough space for ingenuity and innovation, and through genuine collaboration towards our common purpose. Our communication challenge is to forge a more mature relationship with government and other end users of the science that best supports their decisions for environmental management, for climate policy, and for conservation measures. So, how much progress could we achieve? Well, the beauty is that we get to decide, and not just through the scope of our scientific ambition, but by our ability to work together to translate that research into improved outcomes for environmental protection.